In section 1.6, we're going to solve equations and inequalities that involve absolute value. But let's backtrack a minute and make sure you understand what absolute value really means. So that's what the handout starts with. What does the absolute value of a number mean? So if I ask you to find the absolute value of -5, what I'm really asking you to find is the distance -5 is from 0. So if you think about that, if here's 0, over here is -5, and we know that it is 5 units from 0, and that's why the absolute value of a -5 is 5. It's also why the absolute value of +5 is 5, because it's also 5 units from 0. So when we solve the absolute value equations and inequalities, we need to remember that there are two numbers that would fit that distance location from 0. That's why when we go to solve them, we have this theorem. It says if A is a positive real number and U is an algebraic expression, then the absolute value of that algebraic expression equal to that number can be found by either setting U equal to A or U equal to a -8. So we're recognizing that there's one on the right side and one on the left side of 0. So this is the theorem we're going to use to solve these equations. So in other words, we need to write the two equations. I'm just reading the handout based on the original equation. First equation is going to be identical to the original. You just drop the bars. So it's identical to the original. You just drop those bars. The second equation, you're going to keep the left side, but you're going to change the sign on the right side. So let's try one. This is example 1. And again, we're solving. We're going to find the real solutions, if any. And we have the absolute value of 3x minus 1, and that's equal to 2. So using our little template, the first equation is 3x minus 1 equals a +2. I'm going to go ahead and label that with a little 1 to indicate that's my first equation. My second equation is going to be the 3x minus 1. Again, keep the left side the same. Don't change anything. All we're going to do is change the sign on the right side. And now we just need to solve both of these equations individually. They're not related to each other. This is the answer or this is the answer. So if you move the 1 over, you'll get 3x is equal to 3. Dividing out the 3 is going to give you x equal to 1. So there's one solution. Over here, if we move the 1, we're going to get 3x equals a -1, and x equals a -1/3. So we have two solutions that are going to make that algebraic expression true. So again, you can check them. If you plug the 1 back in, 3 times 1 is 3, 3 minus 1 is 2, absolute value of 2 is 2. Plugging the -1/3 in, 3 times a -1/3 gives you -1 minus 1 is a -2, and the absolute value of a -2 is 2. So it definitely works. Okay, let's solve some more like that, following our template of writing two equations. So example 2, we have the absolute value of 2 minus b is equal to a -1. Looks very similar to the last one. Let's go ahead and try it, see what happens. So our first equation would be 2 minus b is equal to a -1. Our second equation, and I usually immediately write that second equation so I don't forget to write it, and I label it. So we have 2 minus b, change the sign on the right, and make that a +1. We can solve these. We'll move the 2. -b equals -3, b is equal to a +3. Over here, -b equals a -1, b is equal to a +1. Let's check them. So if we plug the 3 in, 2 minus 3, so this is me checking the absolute value of 2 minus 3. 2 minus 3 is a -1. And the absolute value of a -1 is +1, not a -1. So this doesn't work. Why does it not work? We didn't have any issues with the first one. Well, it's because of this. This is saying that the distance we are from 0 is a negative. And you can't have a negative distance. So we really didn't need to go through all of this. We should not have gone through all of this. We should have looked at that at the beginning and recognized that it's not going to work no matter what. So our answer is no solution. So be careful when you have equal to a negative number. So word of caution, there's a little sneaky tricks here and there. Example 3. Example 3 says the absolute value of 2x minus 3 plus 2 is equal to 6. Well, unfortunately, our theorem only works if we have the algebraic expression equal to a constant. So this extra term in here is throwing things off. We'll need to move it first. So the very first thing we're going to do before we write our equations is move that 2 to the other side. That's going to give me the absolute value of 2x minus 3 is now equal to 5. And then we can proceed to write our two equations. So 2x minus 3 is equal to positive 5. And our second equation, 2x minus 3 equals a negative 5. You can solve both of those. So 2x will equal 8 and x equals 4. Over here, we'll get 2x is equal to negative 2 and x equals a negative 1. So it works nicely. And again, if you want to write them as a single solution set, with braces, you have negative 1. And again, try to write them in numerical order. Example 4 is a little different because it's got a quadratic term. It's an x squared. How does that impact what we're doing? It doesn't. We're going to treat this the same way we did the previous examples. So we have the absolute value of x squared plus x, and that's equal to 12. So we'll write our first equation, x squared plus x equals 12, and then we'll write our second equation. So x squared plus x equals a negative 12. Solve them one at a time. So because it is a quadratic, we know we need to set it equal to 0 to solve it. So we're going to do x squared plus x minus 12 is equal to 0. Again, that's standard form for a quadratic. This one factors nice and neatly. Factors of 12 that subtract to 1 or 3 and 4. So we're going to have x with a 4, we'll have x with a 3. Because we're subtracting, we know we need one of each sign. The larger factor will take the first sign, which is a plus. This one needs to take the minus. So again, you can FOIL this really quick to make sure that it works. Solving each of these, x plus 4 is 0, giving us x equal to negative 4, and x minus 3 is 0, giving me x equal to 2. So right now we have two solutions. Over here, when we go to do this one, same kind of format, we'll go ahead and move the 12 over to set it into standard form. It's a 12. This time there are no factors of 12 that add to 1, so we'll have to go to the quadratic formula. It's not factorable. We'll go to the quadratic formula. So x would be equal to negative 1 plus or minus the square root of 1 squared is 1 minus 4 times 1 times 12. That's my 4a, see on the inside, all over 2 times 1. Okay, well, if you take a look at the radical, what's inside here is going to be 1 minus 48. We're going to end up with a negative under the radical. And again, these are distances. You can't have a distance expressed in terms of I. So this one yields no real solution. So the only solution we actually have is from the very first one, the negative 4. Okay, one more before we move on to the inequalities. This is example 5. Hopefully you're taking advantage of the videos in terms that you can stop, work the problem, then come back and check as I work the problem. That would be advice I'd give. Okay, example 5. We have the absolute value of x over 2 minus 1/3 is equal to 1. And so this one obviously brings into play the fractions. So equation 1 would be x over 2 minus 1/3 equals a positive 1. We'll immediately write that second equation. So x over 2 minus 1/3 equals a negative 1. Then we're going to multiply everything by the common denominator to clear the fractions. And we'll work one and then go back and work the other one. The common denominator this time is a 6. So we're going to multiply by the LCD. And again, that's in order to clear those fractions and not deal with the fractions. Just a good habit to develop. We'll multiply this term by 6. We'll multiply the next term by 6. And finally, we'll multiply the other term by 6. So 2 goes into 6 3 times. That's going to give me 3x. 3 goes into 6 twice. 2 times the 1 is going to give me a 2. Now on the other side, the 6 won't cancel. So we just end up with 6. Now we have a nice linear equation to solve. So 3x is equal to 8. 3x is equal to 8/3. We'll do the same thing on the second equation. We're going to multiply everything by that 6. 6, 6, and 6. Same kind of canceling goes on. You're going to put the 3x minus the 2 equals a negative 6. So 3x equals a negative 4, and this is negative 4/3. So our solution is that negative 4/3 and the positive